sure.
Yeah, no problem. All right. Well, not that one. This one. All right. All right. Should be live here. Everybody needs to tell me. Someone needs to say hello to me, and then I know that we're actually live.
Hello. Is that Con, or do you mean that you need a fan
Yeah, we need
watching?
somebody from the actual audience letting us know that they can actually see it. So as soon as that happens, then I'll know it's live. There we go. Some people are saying we're live. All right, let's do it. Hi, everyone. So I'm Fraser Cain, publisher of Universe Today, once again for a weekly live QA. Although once again, stumbled into having some amazing guests join me. So this week we've got Dr. Alan Stern and Dr. David Grinspoon from New Horizons. And there they are, and they're live in Seattle, and they're going to be joining me to answer your questions about space, astronomy, but specifically Pluto, the New Horizons mission, and sort of where we are right now. So, David, Alan, welcome to the show.
Hi,
Thanks, Fraser.
Fraser. Thanks for having us.
All right, well, let's get into it. So first, can you give us an update on how New Horizons is doing?
Yeah, spacecraft's doing very well. It is speeding toward its next flyby, which will take place on New Year's Eve and New Year's Day. Spacecraft's currently just finishing up an almost 6-month-long hibernation that will exit on June 4th and begin flyby preparations on board the spacecraft. And we expect to do our first navigation imaging to look for the target in late August and in September.
All right, and then to kind of go along with this, and part of the reason why you're here is you guys are on your book tour for Chasing New Horizons. So now's the time. Hold up the book. There it is.
There we go.
Yeah, Chasing New Horizons inside the epic first mission to Pluto. And it really is an epic story. People watching, you probably heard about New Horizons, and we had a spacecraft that made it to Pluto in July 2015. But you may not know all the backstory.
You certainly don't. And this book, which is not a long read, it's about 300 pages, is the first comprehensive attempt to take people from the idea in 1989 to the fruition in 2015, all the way through the political trials, all the way through the proposal competition, all the way through building a low-cost spacecraft in record time, and then a flight across the solar system.
All right. Well, I don't want to spoiler alert the whole book because you do want people to buy it and listen to it.
Yeah, we should hide the picture on the cover then, so they don't know if we made it to Pluto or not.
Yeah, the word is out. But can you give it, because it really is an epic, and I think this is fairly standard, right? Most people see these missions after they've come about, but can you give us the abridged version of the trials and tribulations that you went through to get this spacecraft to finally get some close-up pictures of Pluto?
Yeah, well, so as Alan said, it starts with a group of young scientists, a small group in 1989, right at the tail end of Voyager. Voyager had been to Neptune. Voyager had done its magic over those years, but Neptune was the last hurrah. And then the question is, well, where do we go next? What's our generation going to do? What's our Voyager? And there was this one planet Voyager had not made it to, even though Pluto was on the plan for the original Grand Tour, but for various reasons, Voyager didn't make it. So then that was the idea that Alan and his gang of rebels had, that like, hey, let's send a mission to Pluto. And they really didn't know what they were doing, but they knew it was a good idea. And they had to figure out the system. How do you get NASA to approve it? How do you get Congress to fund it? How you get it to rise to the top of the ranking within the planetary community? And all the while, it's a shifting target because we're learning new things. We're discovering the Kuiper Belt. We're discovering that Pluto's not alone out there, and there's this whole new third zone of the solar system. And the team goes through ridiculous trials and tribulations and setbacks and cancellations. And they have to just pick themselves up and dust themselves off and keep going. So there's a lot of that. There's a lot of emotion and heartbreak. And I think it's very revealing, not just of their experience, but of how it works, how a mission goes from just as an idea to a NASA project.
But for the nerds, David also wrote, the inside story. There's a chapter on how we really built this for 20% of the cost of Voyager. What were the design innovations? And what was the flight across the solar system like, and what is it like to plan a flyby when you only have one shot at it? You got to look under every rock. That chapter is called Battle Plan Pluto,
Yep.
and you really see things that have never before really been described. And the way David did this, it's not just a narrative. He interviewed me a lot as the mission principal investigator, but he interviewed 24 other people, from NASA administrators to individual flight controllers and other scientists on the team and engineers, the project manager. And these voices are all through the book, from the recorded interviews where David will be talking about something and then someone will speak. And you get to know these people, and they're all through the book. So it's like you're reading a conversation from the team, reminiscing about the entirety of the project. It's quite innovative.
But I mean, I've been doing my job for 20 years, and I remember early on in my job, you advocating for this mission. There was sort of a previous name to it, and there was even a name for this, the Pluto Underground. I mean, I think it really is an amazing story on how long and how difficult and how much politicking and budgeting and scientific, so what are some of the stories of, like, the background stories that you found most fascinating in researching this book, David, and kind of, that if it hadn't come together, maybe the whole mission wouldn't have come together?
Well, gosh, there's so much. It's a very rich story. I love the origins at, there was this AGU meeting, American Geophysical Union session, where Alan and Fran Bagenal, who's another character, she's a planetary scientist who was in this with Alan from the beginning and is still active and part of the project. They realized that they needed to show NASA that there was interest among the planetary science community. So they organized this first session about Pluto at an AGU meeting in Baltimore. And then at that meeting, while they were all in Baltimore, there was this now legendary dinner at an Italian restaurant with this small group, I guess about a dozen planetary scientists. And that's where it began, literally at this table, an Italian restaurant.
So a dozen people made a pact to go and make this happen.
Yeah.
And we didn't have any idea how we go about it, but we just made a pact that we'd stick together and not take no for an answer.
And a lot of them are the people who are now, they were young, trying to decide to, figure out a plan. A lot of them are people who are now still on the team. Alan, Fran Bagenal, Mark Bowie, Bill McKinnon, a lot of these same faces are still with the project. And so just the fact that, that episode marks really the beginning of this journey, and the same people carried through. And then there's this moment in the story where the mission is dead. It's declared dead by NASA. Dead.
Yep,
dead.
I remember that.
Was what one of the NASA administrators said to emphasize the point to Alan that not only was this mission not happening, but NASA was getting out of the Pluto mission business. And of course, that was devastating, but it also, got people ticked off and determined. And then there were several things that happened to resurrect it. And one of them was this huge public campaign orchestrated by the Planetary Society, where letters just started pouring into NASA. And, poor Ed Weiler, who was, the NASA chief scientist at the time, or the head of planetary science, no, he's the head of the associate administrator. He was trying to, hide from the public, and then he'd step outside. Literally, he'd step outside for a cigarette break because was a chain smoker, and people would accost him on the street, protesters trying to save Pluto. People would follow him. So it was really true that there was this public outpouring of support. I mean, of course, the team helped orchestrate this. They knew that this was necessary, but it was also genuine. You can't get 10,000 people to write letters unless there's 10,000 people that care. So that was a real outpouring and showed that the public loves Pluto. And this is something that became part of the story again and again, that they saved the mission. And then, years later, when New Horizons gets to Pluto, the public reaction is overwhelming.
Yeah.
It's just, a billion hits on the website, and all over the world, this like outpouring of attention and creativity on the web, and just the global phenomenon that was the Pluto encounter.
Do you think that lesson has gotten learned yet? I mean, we kind of went through a version of that with the Juno spacecraft where they weren't even sure they wanted to put a camera on it. And then someone said, no, you really should put a camera. And in fact, the camera is going to help send back the greatest images of Jupiter that have kind of ever been seen and get the community, the public involved in a way. And I think, you know, I've mentioned this in the past, Alan, you are the master of outreach for these planetary missions. And was that a tough sell for you?
What a tough sell?
Being so involved and doing so much outreach and sort of connecting New Horizons and Pluto with the public in this way, because
not at all.
I think
I think it's a responsibility we have, and it's an opportunity. And I viewed it that way. In fact, I was out front of NASA and actually found some resistance in NASA in 2014 and 2015. And then even though NASA was putting the brakes on a little bit, all of a sudden the public interest just overwhelmed the agency, and they were just on this tidal wave of Plutomania.
Yeah.
It's interesting you mentioned JunoCam, you know, because that's an example of something that wasn't part of the science mission. It's really just public outreach and exploration, and yet it's been one of the most visible and fantastic aspects of that mission. There's a tension we talk about in the book. Oh, did we mention we have a book?
Yeah, there it is.
There's a tension between the goals of science and exploration, and they often align, but there's not quite the same thing. And there was this idea that, you know, Alan had, and makes sense to a lot of us. Well, we should just go to Pluto because it's exploration. It's a place we've never been before, and that's justification. But it's not justification enough for NASA. They want science goals, science rationale. And that's, you know, again, with JunoCam, it's not strictly part of the science mission, but it's exploration and outreach, and it's awesome. And it's an awesome idea to go to Pluto, obviously, for a lot of us because we haven't gone there before. But it seems like it should be good enough, but it's not. The science case had to be made. And throughout this struggle of the 90s, you know, of the Pluto mission rising to the top, the science case was made. And part of what happened was the Kuiper Belt was discovered, and Pluto went from being just this cool place we should explore for its own sake to the representative of this whole third zone of the solar system that we needed to understand for fundamental reasons of the architecture of the solar system.
Yeah. And, you know, sort of the timing has just been incredible as well. Just that as New Horizons was arriving at Pluto, the understanding of some of these icy, what were thought to be fairly inhospitable worlds has completely changed with Europa, with Enceladus. And now, I mean, you're even saying that maybe there are liquid oceans on Pluto and Charon. What gives?
Not on the surface.
Underneath, yeah.
Right, and we're finding that in the other planets of the Kuiper Belt are as diverse a lot as the terrestrial planets that we have. You know, Haumea with rings, and Eris that's you know, maybe a sort of massive version of Pluto's Sputnik glacier, a global glacier. We find satellites to be common around these worlds. We find volatiles on their surface and signs of activity. And the whole Kuiper Belt is really the dominant class of planets in our solar system, and this great diversity that's begging for more missions to go out there.
Yeah. I mean, so now I guess if you could send a follow-up, now that I mean, you know, these first missions are this way to sort of, it's almost like you don't get to answer as many questions. It's like now you just get a million new questions. If you could send that follow-up, what are some of the really interesting features that you discovered on Pluto that you'd love to get some answers to?
Right. Well, there are studies taking place right now. I'm leading one of them, but there are others as well, looking at Pluto orbiters and how we do that. And we have the technology to do it. Fortunately, Pluto's got a really large satellite named Charon that's massive enough to do the same job that Titan did in the Cassini mission, which is to make close flybys of Charon to redirect the spacecraft all around the Pluto system without using any more propellant, only targeting propellant, not actual deterministic delta V. So we can make close flybys using Charon of all of the 4 small satellites. We can dip down into the atmosphere. We can go up over the poles and come back and really survey the entire system using Charon as our lever arm. And then we've started to look at the scientific objectives and the payload. We're going to be there for years, so we're going to be able to see time variations. We're going to bring instruments that can see in the dark so we can look at changes on the night side and in the polar terrains where there's no sunlight, but we can look with low light level cameras. We want radars to penetrate through the glacier and through the ice down to where the basal melt may be occurring, and you have liquid nitrogen flowing. We want to bring thermal mappers because we found what appear to be cryovolcanoes. Well, are they hot? Are they active or not? We want to bring a magnetometer and a very sensitive gravimetric investigation so that we can actually measure and definitively confirm the ocean that we believe is to be global below the crust of Pluto. And that's just a few of the topics. If you talk to atmospheric scientists, they'd say, I want a nephelometer, which is a device that measures the particle sizes in the hazes that were found to be so ubiquitous. They want a mass spectrometer so that we dip down into the atmosphere and measure all the trace species. It's just a very rich mission. And it's almost something for everyone, between the small satellites, between Charon, Pluto, which is just a scientific wonderland, and to be able to go there and stay for years on end, not just a few days like New Horizons. And we know Pluto's a dynamic place, and to watch it changing is going to be a very, very powerful advancement for the whole field.
And at a very basic level, I want to know what the rest of Pluto looks like. We've got this encounter hemisphere, incredible, stunning detail, and then we've got the non-encounter hemisphere, in much less detail. Fortunately, New Horizons had this telescope on board, only slightly larger than the one behind you there, a very well-engineered Celestron, type telescope on board. And so they could get on approach that other side of Pluto, because Pluto, with its 6.4 day rotation rate, when you're 6.4 days out, you're getting your last look at that other side. And so we can see that it's got interesting geography. It's potentially as interesting as the encounter hemisphere. Who knows? Maybe it's more interesting. So Pluto's interesting enough from what we've seen that we have to see the rest of it. And as Alan said, we can do a lot more than that. We can get time variation and all this other stuff. But I want a map of the entire planet.
Well, and I think one of the things as well is it's one thing to see. I mean, Pluto is a member of the Kuiper Belt. It's one of these objects, but there are many, many, many more of them out there. And now it's about comparisons, right? How are the other ones similar? How are they different? How does Makemake look compared to Haumea, compared to Pluto? You've got this flyby coming up to see a second object. So give people a bit of a preview on what's going to happen with this.
Yeah. Well, let me first say that you brought up something a moment ago that I should expand upon a little bit. There is a tension now in the planetary science community between those who want to go back to Pluto with an orbiter and study it in more detail. Think of it as a vertical mission. It's going to go very deep in the understanding of the Pluto system now that all these questions have been raised by the data in New Horizons. And then others that want to go broad and instead do New Horizons like flybys of, let's say, 2 or 3 or 4 more planet-sized Kuiper Belt objects to start the comparative planetology, to go to Makemake, to go to Haumea that has ring systems, to go to Eris, which is a much more distant one, and start the comparison. We probably can't afford to do both of those things. 3 New Horizons about equals 1 orbiter. And with all the other demands for Mars missions and ocean world missions and Uranus, Neptune, ice giant exploration, we really just can't throw all of our resources at the Kuiper Belt. So we're going to have to make a choice in the next decadal survey between going broad and going deep. And I don't know how that's going to turn out. Nobody does, really. Studies are taking place for how to do both mission sets. Now, with regard to New Horizons,
the preview,
now realize Pluto has a surface area that's comparable to the entirety of the United States. It's a big place. Where we're going is something the size of Chesapeake Bay. It's just 30 kilometers, 20 miles in size. So this is a building block of these planets, but it's not a diverse world like a Pluto or a Charon or a Makemake or an Eris or a Sedna. And so what we hope to learn about is the origin of these planets and what the building blocks were made of, how old they are, how much they have evolved, whether they have any atmosphere currently, whether they ever had activity geologically, And we've never been to anything like this. It's 1 billion miles further out than anything that we've been able to explore in the past. It's been in this deep freeze at roughly 30 degrees above absolute zero forever. So it's probably, we believe, the most pristine and well-preserved bedrock sample of the solar nebula that anyone has ever been to and that anyone is planning to. So we're just going in with our eyes wide open. We're going to fly a lot closer than we flew to Pluto. The images are going to be even more detailed. And the spacecraft's in great shape. It's coming out of hibernation in 3 weeks. And then we're going to crank up and start that flyby operation in August. And then by late December, we will be right on Ultima Thule. That's the target's name, Ultima Thule's doorstep.
It feels a little bad. I mean, there's so much, the spacecraft has so much left in the tank capability wise, and it just doesn't have targets now beyond the next one.
We may very well find another target. We're not concentrating on looking yet because we don't know how much fuel we'll have left to devote to targeting that. So we'll have to wait until after this flyby to know, and then we'll start a search. And I hope very much that we'll find another target, but we also have these telescopes on board that David spoke about. And we have the only observatory in the Kuiper Belt, and that's a very resource. There's science that we can do because we're up close and personal and passing by objects and seeing them at different geometries than you could from the Earth that no one else can. And as long as that spacecraft is in the Kuiper Belt, and the Kuiper Belt is now known to extend out to about 70 astronomical units, this is a once, not only in a lifetime, it may be a once and only opportunity. Remember, if we send a Pluto orbiter, it's not going to be motorboating around the Kuiper Belt like New Horizons can. So this may be the one and only time in the 21st century that we do something like this. So we want to get the most out of it.
And by the way, the drama to discover Ultima Thule is one that a lot of people don't know that is covered in the book. Did we mention there's a book?
Yeah.
Just published 2 weeks ago.
Yeah. It was always part of the plan to go somewhere after Pluto, but they had to find a place to go. And it was assumed it would be easy because they'd have all this time, or not easy, but it would be doable in the time when New Horizons was on that long 9-year trip out to Pluto. That observers on Earth would find the object that New Horizons could reach. But they were having trouble finding it, and the clock was ticking. And so they actually had to press into service the Hubble Space Telescope. And there was a lot of drama. It was just in the nick of time. They discovered what the object that eventually became nicknamed Ultima Thule, that New Horizons was redirected and is now going to intercept this coming New Year's Eve. Likewise, if more objects that can be discovered that New Horizons can reach, then the mission will continue.
Now, our producer Nancy ran into you, David, in at the Air and Space Museum, I think, and she showed you that, in fact, the New York Times cover was the same for 50 years ago, first photos of Mars, and now the first photos of Pluto. And she wanted to know what you think it's going to be in 50 years from now. What's going to be on the cover of the New York Times, if it even exists?
Yeah, that's exciting. That it was 50 years to the day, the New York Times cover with New Horizons, the day after the encounter, and the New York Times cover with first pictures from Mariner 4 at Mars in 1965. That 50 years from the first flyby of another planet that returned pictures to the first flyby of the last planet, in a sense, New Horizons. 50 years from now, one thing I've learned about I did this job at the Library of Congress where I was studying predictions of now from the past, and I decided nobody's good at predicting the future. But one thing that I can say that we've learned just from the history of space exploration up till now is that things are very nonlinear. So extrapolating from current progress to that far in the future, is what we naturally do. And it's usually wrong because there's moments of acceleration like the Apollo decade, and then deceleration, and then acceleration again. I see more acceleration in the future because there are more players getting in the space game with private exploration, and because space flight's getting cheaper and we're getting more capable. I mean, New Horizons is an example of innovation doing more with less. And those innovations now they're cumulative. We have them from now on, and people are coming up with new ones. So I think that 50 years, if I had to guess, I guess I do since you asked me, 50 years from now, we'll have spacecraft all over the solar system. There will be people living multiple places in the solar system, and there will be a lot of industry in space and use of resources in the asteroid belt, on the moon, on Mars. That's my picture.
Yeah, I hope we see it. Now, one of the great things about the New Horizons mission, or I guess, or one of the downsides is that because it's so far, the speed that it can communicate is very slow. So it took a long time to kind of send all that data back, and then time for you folks to crunch through it. So can you give us sort of some sort of fresh off the press, new insights and discoveries that have been made about Pluto thanks to New Horizons?
Well, everything that we know about Pluto, virtually everything, is due to New Horizons.
Like
really,
last couple of months.
Yeah. I just want to make clear for those who might not be aware that I think you could write everything we knew about Pluto on a single piece of paper before that flyby.
We had one picture from Hubble that we had to use on every single story that we ever wrote about Pluto, or artist illustrations before New Horizons.
Blurry.
Yeah.
And I actually made a similar picture of the Earth at the same pixelization, and you couldn't even find the continents. It was so blurred, you couldn't tell the Earth has continents and oceans. It was just a blue blob. So we went from that to images that literally, had we flown over, say, a city at the same altitude on Earth, you'd be picking out individual buildings. I used to say, and I'll say it now, if we flew over New York City at that altitude, New Horizons would be counting the ponds in Central Park. That's how good the resolution was. Compare that to the Hubble, pixels of 500 kilometers across. But we made 463 observations of Pluto and its satellites by 7 different scientific instruments. And every observation is groundbreaking. And I think you could make a fair analogy that we've opened all these presents now. We've skimmed the cream. It's kind of like an emergency room where the doctors are just triaging patients and stabilizing them and moving them on. So we've looked at everything for the easy discoveries. But now we're going back and doing the very hard work of computer modeling to support the conjectures from the early discoveries. And now we're finding that, in fact, for example, the giant split across Sharon's equator, that's 10 times the size of the Grand Canyon, was in fact likely due to the freezing of an ancient ocean inside of Sharon.
Wow.
As the water ice expanded, you know what happens when water ice expands? When it freezes, it expands. That creates a stress, and that stress cracked the planet along its equator. Similarly, we're finding with Pluto that there's now evidence, not just conjecture, but at least circumstantial evidence that the atmosphere has changed dramatically, possibly many times over history. We find, for example, things that look like hanging lakes in mountain valleys, but you can't have liquids on Pluto's surface today. And in order for that to have happened, there must have been a thicker atmosphere. So we're finding forensic clues that Pluto's atmosphere may have been thicker than Mars's is. That's amazing.
Yeah. That's all mind-bending. And I think the other part to this is that all of these questions, of course, these are going to help you define the parameters of that next mission.
Absolutely correct. We know now, getting a mission to Pluto was hard because you had to convince people from not knowing very much about Pluto that it would be right side up on the cost-benefit analysis. Now we know that Pluto is one of the real scientific wonderlands of the solar system. And there's a very strong interest in going back. And everybody is fighting over, will you fly my instrument? Will you fly my type of investigation?
Yeah.
And so the trick here is going to be appetite control to make sure that we don't weigh it down with too much and it becomes too expensive and we get nothing. So we want to find a small, lean orbiter approach that can get there quickly and that can really amp up what we know about the system.
Lander, rover, sample return. I know. I can guess what's in your proposals.
And then we need, a human base.
Yeah, of course, and human base.
Well, and a submarine.
And a submarine.
Yeah. That base should include the ability to drill down into the ocean and submarines.
And helicopter. Yeah. No, that all sounds great. Well, I know you guys. I know you guys.
Helicopters be hard up.
Yeah. That's very thin atmosphere. Well, if they can make it work on Mars.
Climate change.
Yeah. Well, guys, one last time, let's see the book.
Oh yeah, did we mention we have a book?
Yep.
Jason,
and the chat.
By the way, there was one of the journalists who was interviewing me about this book earlier today said something about it that I thought was awesome. He said it reminded him of a Michael Crichton book, except it's nonfiction. because it is a thriller. It's a techno thriller. And even though people know how it ends as a happy ending, we got to Pluto.
You have no idea of the real story.
Yeah. And there's a lot of just like crazy, unlikely moments and gauntlets that had to be survived to get to Pluto. So I think it is kind of a page turner.
Well, congratulations again. And I hope you sell 1 million copies. Oh, and people have been sort of discussing in the chat that there is an Audible book as well. So if you
David read the book, I read the preface and the coda at the end. David read the entire book, and you can do that. And we had one thing for you. We wanted to do something special.
All right.
Oh yeah, the Pluto salute.
The Pluto salute.
Yeah, everybody watching, do this with us. 9 fingers. Hail Pluto.
Hail Clyde Tombaugh. Lover of the 9th planet in the solar system's 3rd zone.
Yeah.
That's awesome. All right. Well, thanks, guys. Good luck.
Thank you.
Thanks for stopping by.
Take care.
All right. Well, we got another half hour, so why don't we stick around and I'll answer some of your questions. Thanks everyone to all the moderators in the chat for bringing a bunch of questions forward that I could see. Sorry I didn't have a lot of time to send some of your questions to them. There's actually a bit of a delay, and I didn't want to interrupt them, so I just wanted to sort of let them talk as much as possible. So, but I was able to get Nancy's question there, which is awesome. So I'm going to stick around for another half hour and answer your questions. We can talk about Pluto. We can talk about anything that's going on in your brains. So I am at your disposal. They mentioned that they're going to be on they're on a 2-week tour right now. So they're going to be Seattle next. They're on the West Coast right now, and so they're going to be touring various places. You should be able to find out where they're going to be doing their book tours if that's of interest to you. So upcoming guests. Last week we had John Michael Gaudet, who I believe is in the chat. Next week, Dr. Paul Matt Sutter, of course, the Ask a Spaceman, is going to be joining me, and we're going to be answering your questions about space and astronomy. And then I think my weekly Space Hangout co-host, Morgan Renberg, is going to join me the week after that. So when I originally had set up this, I was expecting to just be a solo thing that I was just going to jump in and just answer people's questions. But turns out I've got a bunch of friends who want to join me. So things that I'm going to be doing this week, I'm going to be on Skylius's channel over on Twitch on Thursday. If you want to join me over there. Of course, she's got a huge group of people that watch her every week, so that's going to be fun. All right, well, let's get into some of these questions. I see some popping in now. So Crushknot says, hey, Fraser, what do you think about the focal mission to the sun's gravitational lens? So for anyone who doesn't know what that's about, essentially, massive objects like the sun, like galaxy clusters and things like that, act as a natural lens for gravity. And so the idea is that if you can take a telescope, a spacecraft, out to about 1,000 astronomical units away from the sun, you'll be able to use the gravity of the sun as a natural lens. And it would be so powerful that it would actually allow you to see like surface features on extrasolar planets orbiting other stars, like incredible resolution. Now, the challenge, of course, is to actually get a telescope out to 1,000 AU. So, like, what do I think about it? I think it's awesome. Let's totally do it. Gershon Russell. Hey, Fraser, why do you call it poisonous carbon dioxide when I can drink a Coke and be in fine health? Sure, but at a certain point, you can't breathe carbon dioxide and survive. So I can appreciate the distinction of the term, and, I give the quick version where I call it poisonous, but sure, go ahead. It is a asphyxiant. You can't survive breathing carbon dioxide, but yeah, you can have some, but the amount is pretty low. So, I mean, isn't kind of everything, poisonous? Like, is water poisonous? If you can't breathe water, so it's not, but you can drink it. But if you have nothing but water, then you would die. So anyway, it's a definition. Although I don't drink Diet Coke, so. But it feels to me like that's sort of a way for people to kind of go like, oh, then global warming isn't a problem because carbon dioxide is super healthy for plants and you're drinking it in your Coke right now. And I don't think that's entirely true. It's not a great way to approach it. So Quad Lewis says, while creating a title for your chat with Dr. Sutter, would you consider giving it the subtitle in the form of "Let's Get Kraken"? Yeah, that sounds awesome. That's the nickname that we've given Dr. Paul Sutter, is the Kraken. Mostly because he's such a skeptic. And the hilarious thing is, I've become the skeptic too. It's funny. You spend too much time talking with cosmologists and astrophysicists and things like that, and it sort of kills the dreamer into you, where you are thinking about futurism and the far future and megastructures and warp drives and things like that. And then year after year, as you sort of see the state of the actual reality and how difficult spaceflight is and cosmology and how difficult it is to tease out the answers that we already have, you tend to just get a little more realistic, cynical, skeptical. And so I've definitely become a lot more. It's funny, if you go back and listen to the early episodes of Astronomy Cast with Dr. Pamela Gay, I'm the when do we get wormholes and warp drives? But let's just imagine a civilization living at the end of time. And now I think I'm more of the cynical skeptic, which is totally not. I don't know how I became this person. So now I pass on the future wonderment to Isaac Arthur and John McGodier. Let's get another question. There was one there. Oh, right. So thoughts. Ghost World wants to know thoughts on the cancellation of the Expanse TV show. Oh, man. That sucks. So if any of you didn't know, The Expanse is this show that's on the Sci-Fi Channel. The channel about science fiction. I believe The Expanse is really the only show they were doing now. And they have canceled the show. So season 3 is going to be the end. And now we beg Netflix or Hulu or anybody to pick up The Expanse and keep it going, because I think it's the best sci-fi television show on TV right now. I would even go so far as to say it's possibly the best one ever made. So it seems crazy to shut it down. Gordon Dewis, and now you're grumpy downer, Fraser. No, not yet. But I do find myself tending towards the near future of space exploration and astronomy. So I find my interest is on the stuff that's in the next 10, 20 years, 50 years at the most. I'm most interested in missions in the works, in surveys and discoveries that are just around the corner, or the things that have just been made. And I find myself less interested in that really, really far off stuff, just because it just seems so far away. So Curious Borg, even Skeptic Fraser still gets all starry-eyed over solar sails. That is absolutely true. I would love to see, the Planetary Society is doing their light sail 2, and they're going to be doing that test. And it's unfortunately their mission has been pushed back. So I think because the Falcon Heavy they're going to be launching on has been pushed back. So at this point now, we're still a couple of years away from the sort of first proper test of a solar sail in space. And these solar sails could very well be the way that we travel from world to world, that we even travel from star to star. So it would be great as soon as this technology can get developed. Krishnan, do you ever think you get Paul Gilster on here? Probably, yeah. I mean, we had him on the Weekly Space Hangout. Let me write that down. Nancy, if you're watching this, I will totally, we should totally get Paul on this show. We had him on the Weekly Space Hangout. Wasn't enough time. So for people who don't know, Paul Gilster is the publisher of Centauri Dreams, which is absolutely one of my favorite sort of space news websites. A lot of great essays and research on interstellar travel, research like that. He tends to go in the sort of in that sort of more advanced direction and does some really great reporting. Most of it's completely original. So the stuff you're going to find on Centauri Dreams is no one else is reporting it. While everyone else is sort of chasing the same press releases, Paul seems to find his own sort of inside topic. So I highly recommend it. Centauri Dreams. And I'll talk to Paul. He's a party, so it'd be fun. Jerry Rice, Fraser, what do you think is going to happen first? Breakthrough Starshot or a manned landing on Mars? So first, just want to give an official title. I'm no longer going to use the term manned and unmanned. I'm going to go with crewed and robotic. That's the new terminology I'm going to be using. Man, that's a good question. So let's see. What's going to go first? Breakthrough Starshot or a crewed landing on Mars? So I would say Breakthrough Starshot. The crewed landing on Mars is going to happen first. We should see probably the first, assuming that SpaceX follows its current flight plans, we should see, I don't think we're going to see the first BFR head off to Mars by 2022 and the first humans going by 2024, which is the original schedule. But I would say probably by the end of 2020, so maybe 2030, we're going to see those first footsteps on the surface of Mars and maybe a return. 2040 at the latest. Not from NASA, but probably from SpaceX. But we'll see if they actually pull it off. And then for the breakthrough Starshot, I think there's still a lot of technology that needs to be developed to be able to do this, to be able to send those first probes to Alpha Centauri. You need to build the propulsion system. You need to build the materials that will be able to make the light sails work properly, ways to be able to communicate the signals back. You're going to have to daisy chain the signals back. I would be surprised, I think we can see the breakthrough Starshot start to happen here in the solar system. And I'm actually kind of surprised that I'm really surprised that the folks at the breakthrough Starshot have gone straight for the trip to Alpha Centauri and not just use this technology to explore the solar system, right? Imagine you built thousands of these little probes and you just sent them on various trajectories out into the solar system. They could be orbiting tons of asteroids and planets and moons and Kuiper Belt objects and all kinds of things, and get there really quickly and build this enormous sort of network of communication across the entire solar system. That really feels to me like that's the first use of this technology. And if we get to the point where we've got this infrastructure that can actually handle this, then we can start to send these probes to other worlds. But that's just me. But I feel like and that would be an amazing accomplishment. It would bring down the exploration of the solar system by orders of magnitude. And yet people would feel like that is a failure because we're not actually going to other stars. Our solar system, is Alpha Centauri is just another solar system, right? You're going to find planets and Kuiper Belt objects and asteroids and stuff. So we've got lots to discover here. Yeah, John Michael Godey saying, send them into Europa to check out those plumes. Yeah, exactly. Send 1,000, right? If they're that cheap and you can send that many. We should be building, I really feel like we should be building a proper solar system infrastructure. There's a lot of things that could be built. I'll give you a good example. When you look at, say, Mars has so many spacecraft there now that you don't have to, when you send a mission to Mars, you don't have to send something capable of communicating back on Earth. It doesn't need a big transmitter anymore. All it has to be able to do is transmit to any one of the other spacecraft that are already at Mars to perform a communications relay to get that information back to Earth. So I really feel like it's that space infrastructure. Build some of these laser arrays so that they can accelerate spacecraft in different directions to different places. That is what I feel is going to sort of take us to the next level anyway. GP is asking, is there any mission that will analyze soil on Mars for bacterial life? So the next mission that's going to the Mars Insight mission just is off to Mars right now, and it's going to land in about 6 months. It's going to be searching for volcanic activity inside Mars. The next mission after that is going to be the Mars 2020 Rover, and it is sort of like a twin of Curiosity. And they just announced yesterday that they're going to be putting a helicopter on board the rover. And so this tiny little helicopter is going to be about 2 kilograms, is going to be able to launch from Curiosity, fly around, map the whole area, land again, and do this. So you can imagine the Mars 2020 rover being able to study a lot more of the area. And the cool thing about the Mars 2020 is that this is its job, right? Curiosity was there to search for the history of water on Mars. Mars 2020 is there to find out, has there ever been life on Mars? Are the conditions for life on Mars there now? And it's going to be looking, it's going to be sampling the air, it's going to be sampling the ground, it's going to be looking for the kinds of structures that form thanks to life here on Earth. And it's going to potentially be, making sample packets that can then be returned back to Earth. So Mars 2020, that's going to be the one that's going to finally sort of come back and start searching for life. Let's get another question. Zeror, what about Enceladus? We should be able to drill easier there because its crust is so thin compared to Europa. Yeah, I mean, the same technology to drill on Europa is going to be the same technology to drill on Enceladus. And we don't know really how thick the ice is. It might be that those tiger stripes are just one tiny little thin point in Enceladus, and the actual, because remember that Enceladus is further from the sun than Europa is, so it receives less heating. It's also, orbiting a less massive world than, Saturn is much less massive than Jupiter, and so the tidal flexing could be lower. So we really don't know. We need to map out Europa, and we need to map out Enceladus. So after we've sent the one mission, the Europa Clipper has gone to Europa, then another mission needs to go to Enceladus and map out Enceladus as well. So it's not an either or. Go to all the places, all the things. Larry Beckham is noting that the Mars thing is a duocopter. Yeah, it has two propeller blades that orbit in opposite directions, and I think they turn 3,000 RPM, which is about 10 times as fast as they go as helicopters turn here on Earth. Colt 183, is it possible to vape in space? No, because it's not possible to breathe in space. So you would maybe vape once, right? You would vape inside your spacecraft. You'd go outside, and then as soon as you went outside the spacecraft, all the air would immediately rush out of your lungs to equalize the pressure. And I guess that would be you vaping, and then you would die. So you get one. Cyanide Junkie, is the radioactivity low enough? Yeah, that's one of the good things about Enceladus, is that the radiation environment around Enceladus is going to be lower than what it is on Jupiter. And I did an episode about this mission to drill on Jupiter, and it's brutal, right? The environment on Europa, anywhere near Jupiter, is enough to kill a human being momentarily. Right? It's awful. And in fact, they say that one of the ways that they would be able to disinfect their spacecraft is just leave it on the surface of Europa for a while, and it would just be blasted by radiation from the Jupiter environment. So, being at Enceladus would be a lot better. Dylan O'Donnell, why don't we see much video from space missions? Always stills. Well, I don't know of any, and I mean, you know this, right? I don't know of any missions that have video cameras. It's that they have big black and white CCDs that they are putting different filters in front of their camera to be able to take it. Now, I believe one of the plans originally for the Curiosity rover, I think it does have one of its cameras is capable of doing HD video, and originally they were going to have two cameras that were the same size, and so it would sort of do binocular vision and let you see almost like 3D. And they ended up, because of budget reasons, they had to do two different sized cameras, so they weren't able to do that. So, but videos just isn't that necessary in space, because the time frames are so long and slow. Better to take really nice high quality images with a CCD and then stitch them together into video here on Earth. Let's see. Yeah, Curiosity has a video camera on board. And Arnstro notes that trying to get data back from NASA's Deep Space Network is already trying to shove a fire hose through a straw. Video would make that even worse. I think that's important. We didn't bring this up really in talking with the New Horizons folks, but it took them a year and a half to transfer all of the data that was gathered in that one day of the flyby when New Horizons went past. The the bandwidth to send this back to Earth is so slow, and the further you go, the harder it is to get any of that data back to Earth. So it's just rough. Arjun, what would be necessary to increase the bandwidth of communication with deep space missions? And this goes back to that infrastructure concept that I was talking about. That I think one of the, as we see more spacecraft sent out into space, we're going to see more of this infrastructure. You're going to see bigger communication systems that can be used by other spacecraft. So you don't have to send a great big radio dish with every spacecraft, just one that can transmit locally, and then have your spacecraft be able to transmit, have the big communications relay send that information back to Earth. So it would be nice to get some really big, I'll give you an example. There's this mission plan to send like 50 little tiny CubeSats out to the asteroid belt to collect data on like 10 different asteroids each. And the problem is that they can't actually communicate in any of that data back to Earth. And so we have to wait like 3 years for these missions, for these asteroid missions to go past the asteroids, gather the data, then come back in orbit, and then transmit all of their data. And you're going to see this again and again with some of these more complicated things. This is one of the reasons why you can't do CubeSat missions to other worlds, is there's no easy way to send the communications back. But if we can get to this point where there's this solar system sized network of communication satellites, then more and more missions can be cheaper and sent in all kinds of different places. So that would be great. I would love that. Malik Omar, your videos want to make me become a space nerd. Well, thank you. But I believe watching a live stream of a guy answering questions about space and astronomy, I have some bad news for you. I think you already have become one. Christopher Brown Floyd, would you be able to play Crisis on an internet that spans the solar system? The lag would be the killer, right? Would you be willing, how many times would you get taken out because you were having to deal with a 24-hour ping time? GP, what do you think of the space mini nuclear power plant NASA announced it has created? I think it's a great idea. We reported on this on Universe Today. I was thinking of doing a video about this. Let me know if you want that. Because space power is actually pretty interesting. There's solar power. There are the RTGs. And in fact, a bunch of Soviet missions used nuclear power in the past. So, second. Yeah, a bunch of Soviet missions used fission reactors, and now NASA is working on a new fission reactor that could help power Mars colonies, lunar colonies, missions like that. And I think it's a great idea. It's really tough to get enough power, and you could see things like the next video. It's going to get dropped tomorrow. It's all about ion engines, and powering ion engines is the problem. You hook up a nuclear reactor to an ion engine, and you've got like the most efficient, most powerful way to explore the solar system. And you could run these ion engines for days, months, weeks, years, and have the nuclear reactor going for the same amount of time. Now we're cooking. Quad Libet is saying, so send CubeSats in a string so they would relay the data back to Earth via themselves. For sure. I mean, if you send CubeSats, you're going to need to send them in some kind of relay so that they can communicate with each other and to be able to send that data and daisy chain them back. And this is the idea, right? That you would send, say you wanted to do that breakthrough Starshot mission and actually send spacecraft to Alpha Centauri. If each one is just a couple of grams, how is it going to be able to transmit anything that it sees back to Earth? If you send a mission to Alpha Centauri and you don't get any pictures from Alpha Centauri, what was the point? And so you would need to daisy chain. You would send just thousands of these tiny little satellites, and then they would daisy chain data and just relay information back to Earth. So that would be, I think that's what you would want to do. And it's sort of same thing here in the solar system. And so I think that's the goal, is to build more and more of this space infrastructure. I mentioned this in a recent QA, right? Like, gravity wells are for suckers. You don't want to be down in a gravity well. You want to be out of the gravity well. You want to get as much of that infrastructure as you can out, off Earth and out in space. Get those factories going out in space. Then it becomes, almost free. Self-replicating robotic factories traveling across the solar. Wait, now I'm starting to turn into a futurist again. Let's see. Let's get another question here. So Neil Yu. Fraser, have you heard of the Mach effect drive being worked on by SSI and NASA Breakthrough? I haven't heard of the Mach. Can you provide some more information? You're not talking about the EM drive, right? Curious Borg says, could the CubeSats be crewed by tiny Borg? Yeah, of course. We'll all be assimilated adorably. Charge Ale. Gravity wells are for suckers. I want to see this on a t-shirt. That would be great. A.V. Scott and Flower. Fraser, please terminate SLS. Oh, like it's as a Canadian, it's my responsibility just to have the Canada arm, just go over and just pluck it out of the NASA line items of the NASA budget. Okay, so SLS, right? Like right now, there is no way to send humans beyond low Earth orbit. And the only way to send humans to low Earth orbit at all is on a Russian Soyuz rocket. So what's wrong with building a new launcher? Now, I understand it's incredibly expensive. And obviously, SpaceX is trying to make SLS ridiculous and unnecessary, right? With the BFR and with the Falcon Heavy. Although the Falcon Heavy isn't powerful enough compared to the SLS. The SLS is a ridiculously powerful rocket, right? 70,000 kilograms, 70 metric ton payload capacity, and eventually the final version 130 metric ton payload capacity, which is more than the Saturn V. Like, that's a big rocket that's going to send humans to the moon and start building the capacity to be able to go to Mars. Now, obviously, if SpaceX shows up and they test launch the BFR next year and it works, and then they test launch it to orbit in 2020 and it works, and they build the first stage and both stages are reusable and they work, then nobody in their right mind would continue on with the SLS. But I think to also shut down your rocket program because Elon Musk has made a promise is, I think, unwise. I wouldn't do it. If I was in charge of NASA, I would not cancel the SLS, right? Until the BFR was actually flying and it was happening. Because, we've gone through this point where people are like, when are we going to go back to the moon? When are we going to the back to moon? And now the spacecraft is being developed. It's going to be capable of doing that. And now people don't want it to be built. Like, I understand that it's expensive, and of course, as a Canadian, it's not my taxes, so it's not my problem. But it feels like, NASA gets the same budget that it always gets, and now some of that money is being spent on building a new launch system, and they're never as efficient, and they're always full of compromise, and they're never what you want. But the work is being done, and let's let them. And maybe it very well be. It's going to be an end of an era. It's going to be the final. The SLS is the final rocket that NASA ever builds. And then it's the BFR and the New Glenn and whatever comes, and the Vulcan and all these new rockets provided by various contractors at reasonable prices. That'd be great. Let's totally do that. But I think right now, again, if I was running NASA, I would be like, let's not wait on Elon Musk's promises and timelines. If he delivers things that work, then great, use them. Otherwise, assume the worst and hope for the best. So that's my feeling on this. And so that's why I think everybody is, and the way NASA is hedging its bets is that they are SpaceX's top customer, right? They buy more launches on SpaceX rockets than anybody else. They sort of single-handedly stopped that company from going into bankruptcy, and they are helping to float it. So here you go. I think right now, having this competition is fantastic and amazing, and knowing that Jeff Bezos is coming in with Blue Origin is amazing to put pressure on SpaceX, as opposed to SpaceX just getting a monopoly. So I'm stoked. Well, we've reached the He's got involved. Well, then fix James Webb. Oh, every time I even think about James Webb, I just get terrified. I'm so scared about that telescope. I really, really need that to happen. So, and like I said, I'm going to encase James Webb in glass, and I'm never going to launch it so it can never be destroyed. That's my plan with James Webb. It can never have my heart broken. All right, I'm going to wrap this up. Again, thanks so much to Alan Stern and Dave Grinspoon for joining me. Totally check out their book. And the next thing we're going to be doing, of course, is the Weekly Space Hangout. That's going to be on Wednesday. Dr. Ethan Siegel, author of Treknology, I don't have his book handy, is going to be our special guest. And then, of course, Astronomy Cast on Friday, and a new episode all about ion engines is dropping tomorrow, and a new QA is already in the can. That's going to be dropping on Thursday. So we got cool space shows and news every day this week for you. All right. As Parano 001 says, smack that like. Thanks, everybody. We'll see you all on this next week with Dr. Paul Matt Sutter.